The progression of multiplication begins in grade 2. Here, students are expected to take a square and turn it into a 5 by 5 of rows and columns. The purpose of this is to show that the repeated numbers, so for here being 5 plus 5 plus 5 plus 5, is essentially the same thing as 5 times 5. Then in 3rd grade, students use a model. They take their understanding of the model and convert it into a pictorial image of that model. Essentially, this matches this. There are 1, 2, 3 columns and 1, 2, 3, 4 rows. So here, this is 1, 2, 3, 4, 1, 2, 3 columns. Important to emphasize that even if you were to flip this model so that it reads 1, 2, 3, 4 columns and 1, 2, 3 rows, it is still the same thing. There are still the same amount of units in it. By taking that matter, we go to understanding the relationships between multiplication and division. For example, when saying 15 divided by 3 is a number, 3 times that number is 15. In tiles, you can figure it out. If we take 15 tiles and we put them in rows of 3 until they run out, we see that in each row there are 5. 1, 2, 3, 4, 5. You can also use this. For example, if there are 5 cherry baskets and each basket has 60 cherries, students will naturally want to use their unit blocks and group it up like each little block containing 10 units. This information can be transferred into an area model. For here, we still have 1, 2, 3, 4, 5 groups and 1, 2, 3, 4, 5, 6 blocks containing 10 units. So it's still the same, it's just a transfer of information onto an area model. Then by grouping it, you can see that if each one contains 10, there are 3 groups of 100. It is the same as 100 plus 100 plus 100 equals to 300. Or it can also be seen as 3 groups of 100. So students need to get really comfortable with using these pictorial models. And after getting them used to the pictorial model, we'll switch them over to a model that looks like this. It's the same thing, just no drawings, only using numbers. Here we're just having them use numbers that represent their picture. Then we'll progress to a model that looks like this. All of these ones get multiplied together, and that's how we get this 5. Multiplying 5 and 10, we get 50. After doing that for a total of 6 times, this is what we get. So this area model simply reads 50 times 6. Or it can also be read as 5 times 60. All of these are all about making connections. We start off a little bit complicated, then we simplify until it's simplified even further. Then in 4th grade, we move to double-digit multiplication. We're still using the area model, but now in the 4th grade level, the numbers are getting bigger. For example, we have 15 times 17, which gives us the opportunity to use bigger blocks. Here, the students can now see that we are using 2 100 blocks, 1, 2, 3, 4, 5 tens, and 1, 2, 3, 4, 5 ones. So when we multiply everything and add the products together, we get 255. And the students can draw a simpler area model. Then we move on to a numerical area model. So here we have one group of 100, one group of 10 tens, which is 100, 1, 2, 3 groups of tens made by ones, one group of 2 tens, and one group of 5. 200 plus 50 plus 5 is 255. Students will naturally freak out when they see this many ones. It is very easy to get confused, which is why we can move on to the box method, also known as partial products. Here we'll do 10 times 10 is 100, 10 times 7, 70, 10 times 5, 50, 5 times 7, 35. When you add up all the products, you get 255. Once the students understand this, we can move on to this algorithm. The 5 times 7 is 35, 5 times 10 is 50, 10 times 7, 70, 10 times 10, 100. We'll begin by doing 5 times 7 is 35. Carry the 3. 5 times 1 is 5 plus 3, 8. Put the 0. 5 times 7 is 1 times 7 is 7. 1 times 1 is 1. Add it up. 5. And work with a model like this. And this 0 is coming from these zeros. But this will be reached at the end of 5th grade level.